I'm Christina.
And I'm Mackenzie.
And this is the physics of making cookies.
First in our recipe we add Crisco. The Crisco has a mass of 0.141 kilograms. When dropping it from a height of 0.2 meters, it has a potential energy of 0.277 joules. When it falls to the bottom of the bowl, all the potential energy is converted to kinetic energy. Next in our recipe we add brown sugar. The brown sugar has a mass of 0.216 kilograms. Using the equation weight equals mass times gravity, we can calculate the weight to be 2.12 newtons. Using the equation velocity equals acceleration times time, we can calculate the velocity. Since the brown sugar falls for a time of 1.3 seconds, it falls with a velocity of 12.753 meters per second. Now it's time to add milk. The milk has a mass of 0.017 kilograms. Using the equation power equals force times velocity, we can calculate that the milk falls with a power of 1.8 joules per second. After we add milk, then we add vanilla. It falls with an acceleration due to gravity, which is 9.81 meters per second. After we have now added all these ingredients, it is time to mix them. The mixer has a period of 1.127 revs per second. Converting this to radians, it is 7.084 rads per second. The acceleration is always constant when mixing. The mixer has a radius of 0.04 meters. Using the equation tangential velocity equals radius times angular velocity, the tangential velocity equals 0.283 meters per second. When set on setting 2, the mixture has an angular velocity of 5.5 rads per second. It also has a tangential velocity of 2.2 meters per second, as well as a constant acceleration. After mixing, it is now time to add an egg. The mass of the egg is 0.058 kilograms. We crack the egg, then drop it from a height of 0.2 meters. The acceleration of the egg is due to gravity, 9.8 meters per second squared. While holding the egg, there is a normal force pushing down on the egg. The weight of the egg is pulling down a force of 0.57 newtons. An upward force is also exerted on the egg by the hand. After mixing, it's time to add the dry ingredients.
All of the dry ingredients will fall in with an acceleration due to gravity. Now we add flour. Next we add salt. And then we add baking soda. Now we add all the dry ingredients into the mixer. Once all the dry ingredients are on the mixer, we turn on the mixer and mix it up.
Finally, we add in the chocolate chips.
After we add in the chocolate chips, it's time to mix them.
After we have finished mixing, it is now time to roll out the cookies and put them onto the pan. This cookie has a mass of 0.031 kilograms, and it also has a volume of 1.414 times 10 to the negative 5 meters cubed. It falls with a force of 0.3 newtons. This cookie has a mass of 0.036 kilograms, slightly bigger than the other cookie. It falls with a force of 0.35 newtons. After we've rolled out all the cookies, it's time to put them in the oven. Now let's talk about what happens in the oven. According to the first law of thermodynamics, the internal energy, U, of the cookie is 543 kilojoules. The heat added, Q, is supplied by the oven, and the work, W, is performed by the chemical reactions inside the cookie. Through convection, heat is carried from the oven air to the cookie, according to the second law of thermodynamics. Due to thermal volume expansion, the cookie's volume triples, from 1.414 times 10 to the negative 5th meters cubed to 4.24 times 10 to the negative 5th meters cubed. The cookie has 130 calories. If we convert this to kilojoules, each cookie has the energy of 543 kilojoules. Each cookie undergoes a temperature change from 0 to 190.6 degrees Celsius. Using the equation heat capacity equals heat energy over change in temperature, we can calculate the heat capacity to be 2.85 kilojoules per degree Celsius. Using the equation specific heat capacity equals heat energy over mass times the change in temperature, we can calculate the specific heat capacity to be 94 kilojoules per kilogram times degrees Celsius.
And now it's time to take out the cookies.